In this video, what we're going to do is try to find a root of some function f of x by using what's known as the Newton-Raphson method. So we're just going to have a look at a general way how this sort of method works. So what we do is we pick a point here, or close to it. For the sake of this video, I'm going to take this point here. Okay, and then from this point here, if I just click this here, we'll call that x0. Some books call this x1, it doesn't really matter. Okay, what you do is you draw a line up until you hit the curve. So this is the point x0, f of x0. Okay, so this distance here is also f of x0. Okay, and then at that particular point you draw a tangent and you get a new value called x1. And we say that is closer to this root than the first value. And then what we do is we repeat the process. So we draw another line up, we get x1 f of x1 and draw the tangent up there, and we get another point here called x2, which is even closer to the root, and we will repeat the process. So there's a third process there, so we've gone up, there's a third place there, new tangent, and we can see that actually the approximate value and the real root almost coincide in this particular example. Okay, there is a formula for it, and I'm going to look on how the proof of the formula. This is the formula, and this shows you how to get to the formula, but I'm going to show you something a little bit more clearer on how to get the formula. So, taking the sort of first iteration only, so what we got here, is an angle of theta. Okay, and this distance here will be x0 minus x1. Okay, this distance is f of x0. F of x0. We have the angle theta here, we know this is a right angle triangle. So if we apply a little bit of trigonometry to this side here is the opposite side, this length here is the opposite side, and this length here is the adjacent side, and we know that tan theta is opposite over adjacent. So the tan of this angle is opposite over adjacent. So applying it in the terms we got, we have that tan theta is going to be this distance here, which we write as f0, divided by this distance here, which we write as x0 minus x1. Now, I now move this up here and move this down here. I now get that x0 minus x1 is equal to f of x0 divided by tan theta. Now I really want to find what the value of x1, because I want to have the next value to start with. So I put in x1, and that will be x0 minus f of x0. Now tan theta is the same as the gradient of this line, because the gradient is this distance divided by this distance, and in calculus we get the gradient by dividing the derivative of this curve and putting the particular value of x into it. So that will be the same as doing f dashed of x0. So this is sort of my general formula. So x2 would be equal to x1, f of x1 over f dash of x1, and so on. So the general formula is x of n plus 1 is equal to x of n minus f of xn divided by f dash of xn. And this is known as the Newton-Raphson method. You should be wary that it does not always work. Sometimes the tangent will diverge, and sometimes it can also lead you to get the answer for the wrong root. Okay, to find the initial value to start with, to know that there's a root there, you only have to take value either side of the actual root. Here it will be negative, here it will be positive, then you know there's a root. Okay, so we just go back to the GeoGebra applet at one go. Of course, obviously, the closer you take this to this particular point, in this sort of situation, you can do this with a slider. Obviously, they're going to coincide on the real root much earlier. Okay, so I'll just repeat this GeoGebra applet I will put in the notes of the video. This has been a video to show for the introduction of the Newton-Raphson method. I hope you've understood, and I thank you very much for watching.